Okay, so today we'll continue on. Let's see. In our lectures about R, we're talking data structures, and I think we got started, and we said I think I showed you this on Monday, and this is probably covered in Stats 20 already, but it's worth going over again. Okay, we have homogeneous types, meaning all the values within that structure are of the same type. And then you have heterogeneous types, ones where you can have different kinds of data. And when we're talking about data types, we're talking about issues such as, is it an integer? Is it a floating point number? Is it character or whatever? Oh, my bad. I totally forgot. Let's do our online attendance poll. Okay, so you're going to go to onlinepoll.ucla.edu. Okay. Now, and this is important. Don't. I mean, you guys are here, so you should respond. But if for whatever reason one day you miss class, okay, you stay at home, don't try to cheat, okay? It's true. It's possible for you to log in remotely from home and respond to the poll and say that you're here, okay? I haven't created the poll yet, okay? I'm going to do that right now, okay? Okay, we'll give the website a moment to load. And let's see, we are stats 102A-001. Okay, and I'm going to go ahead and click Quick Poll. Does that work? Okay, there we go. Okay, so we have, I've created a poll here, and it doesn't matter, just pick an answer, A, B, C, D, or E, okay? And whatever letter you'll get credit for it, okay? Now, if you miss class, just accept that you have missed class, and that's totally fine. Just don't try to cheat the thing, okay? If you get caught cheating, then you will forfeit your entire attendance portion of your grade, okay? So that's not for that, okay? All right. Are there any issues here? Just, you got to make sure you have your phone and you can log in. Yes, question. It's not working for you? What do you mean it's not working for you?
It's taking me to a page that says terms of use.
Takes you to a page that says terms of use?
Yeah.
Is that happening to other people?
You just press agree.
Yeah, there should be an agree button. Okay. All right. Anybody else facing issues? Okay. So if you arrived to class late, okay, and you didn't see me create it, just go to onlinepoll.ucla.edu, and if you see a poll, respond to it. Okay. That's all. All right. And then if you forget your phone and you can't do multi-factor authentication, just you'll lose the point for the day, okay? It's not that big of a deal, okay? We're going to take attendance probably something around 20 times during the quarter, and all 20 of those opportunities will add up to 3 percentage points. So if you miss one of them, not a big deal. Please don't send me emails and come to my office saying you need your attendance point back, okay? Just the system's not even set up to handle something like that. So, okay. Anyway, anybody else having issues with the online poll? You should be able to log in and view it and whatever. Okay, as long as you're registered for the class. If you're not registered for the class, then it won't appear for you. But and yes, you need to attend your assigned lecture because the poll system uses the registrar's info to kind of create permissions for who can log in. Okay. All right, okay, so we're going back to our data structures, and we've got the homogeneous types, which are the atomic vectors and the matrix. Okay, we also have arrays if you want to go into n-dimensional structures. So matrices are two-dimensional. You know, they look like rectangles, and if you have multiple things, so you have like a rectangular prism or a cube or whatever it might be, or higher, a hypercube. Those are n-dimensional structures. They're all homogeneous. You have to have data of the same type. Okay. Lists are considered generic vectors. Let me see if I could zoom in here for you guys. Oh, I think that's better. All right. And we've got that. Okay. R supports these different data types: logical, double, integer, character, complex, and raw. The first four are the ones that we use most frequently. Let's see, frequently. Okay, complex and raw do exist, but not something that that we worry about. Probably. So I don't, in stats 20, what'd you guys use? Mode. Okay. Mode will return numeric for both of these types, and so I like to distinguish between integers and doubles, and so I like to use type of, okay? And then there's something called class, but that's for S3 object types. So let's just talk about type ofs. Okay, atomic vectors, as stated earlier, all have to be of the same type. We've talked about logical vectors, which contain values like true or false. The letters capital T and the letter capital F are default assigned the values true and false, but they can be overwritten. The word true in all caps and the word false in all caps cannot be overwritten, and so so I recommend using all caps true and all caps false. When you switch to, say, Python, it's capital T lowercase RUE, and same with false, and it's just something you gotta get your brain used to, okay? But in R we use all caps true, all caps false. Characters, anything that happens in quotes is a character string, okay? And vectors, whether you use single quotes or double quotes, it doesn't matter. They will be recognized as character strings. You just have to match up. If you open with double quotes, you got to close with double quotes. And if you open with single quotes, you can close with single quotes. And that allows you to include things like apostrophes. So if you open with a double quote, you can use a single quote, an apostrophe, and close with a double quote, and it'll be okay. All right? And likewise, you can do also like, this looks funny, but that will okay. So this if you want an apostrophe, probably the double quotes is the preferred method, but it requires you to hold the Shift key on your keyboard. Oh, sorry, I keep remembering all of these other things. I posted your first homework assignment. That's on CCLE, and so you can respond to that. You can fill that out. That'll be due 1 week from today at 6 o'clock, so 6 p.m. next Wednesday. So that's available. The instructions are there. Should be clear what you need to do. Okay, the default numeric type is double. So if you type in 1, 2, 3, that will be double. Okay. On the other hand, if you use the colon, 1:3, which they look like the same thing, right? So if you have C 1, 2, 3, and you have 1:3, they look like the same thing. If I call this thing D and this thing I, okay, D looks like that, I looks like this. You can see in the environment it distinguishes. It says D, it says num, meaning type double, and here it's integer, okay? And when you ask type of D, it'll say double. Type of I, it'll say integer, okay? Does it matter? Yes, it does, okay? they're stored differently in the computer, and things are handled differently. Okay. When we combine things, we just use the letter C. Okay. So C is how we create our vectors, and when you try to like nest a vector within another vector, it just flattens it out. Okay, an atomic vector inside. So here we're combining the value 1 with another atomic vector 2, 3, and it flattens it all out, and it just gets 1, 2, 3, right? And what kind of, is this double or is this integer? This bottom one. Double, okay? It's the default. When you just type numbers, double type, okay? You can always ask type of, and if you want a true false, so if you ask type of, it will say something like double or integer. It'll return a character thing that says double. It'll return a character thing that says integer. On the other hand, if you want true or false, you can ask, is it double? Is it logical? Is it character? Things like that, okay? And then if you don't care if it's double or integer, you can just ask, is it numeric? And that will return true for doubles and integers. Okay. Is integer 3 true or false? False. Is integer 3:6? True. Is numeric 3:6? True. Is double 3:6? False. Okay, good job, you guys. All right. Is atomic is if it's an atomic vector. Is vector will return true if it's any kind of vector, whether that be an atomic vector, which is what we're talking about, or whether it is a list, okay? So vectors, is vector will return true basically if there is no dimension attribute, whereas is atomic will return true if it's atomic, which atomic will also return true if you give it a matrix, because a matrix is atomic, okay? So I guess if you want to know if it's a atomic vector, you have both is atomic and is vector has to be true, okay? Otherwise, if is atomic is true, could be a matrix or an atomic vector. Is vector true, could be an atomic vector or a list. All right, I think you probably have experience with this, but R is dynamically typed, meaning you can play loosey-goosey with the types, and R will just coerce it to the least restrictive type, okay? And it doesn't complain. Whereas if you've ever worked with a strictly typed language, such as C, I don't know if any of you guys took Pick 10 or something like that, and you have to deal with C, you'll know that those are strictly typed, and you declare something as an integer, and if you try to do some kind of mathematical operation that results in a decimal, either it's going to throw an error or it will smash it down into integer and drop all the decimals, right? So those are strictly typed languages, and that's what happens. R is just kind of like, we were dealing with integers, but now you want decimals. Okay, I'll give you decimals, all right? And so when you combine things, it's going to look at the least restrictive type and coerce them accordingly. So here we're looking at a number double 1 with the string hello, and it says, okay, well, we'll just coerce the 1 into a string, okay? False is logical. It sees an integer 1L, okay? And it says, okay, let's coerce the false into an integer, and it turns it into 0, okay? 1.2 is double, 1L is integer, but it will say, oh, let's turn this into type double, and it turns everything into doubles, okay? You know, I probably need to modify this slide to include one more. Okay, so logical, integer, double, character, and list. So technically list is also another vector type, which will be the least restrictive form. Okay, so anyway, I don't want to Okay, I'll go ahead and re-render. I didn't want to do this because it takes some time. No, I'm not going to. All right. So anyway, so just imagine there's also a list here, okay? And so here I've got a logical true, false, true, integer, double, character, and if we combine the logical, integer, and double, it's going to coerce them all to double and do this, all right? Whereas if I go logical, double, character, it's going to coerce everything into character. And so what happens to the true, false, true, when we coerce to double, we'll go 1, 0, 1, whereas if I coerce to character, it's going to go directly to all caps true, false, true, right? And so there's a few things that are different, right? If we can do something called explicit coercion, where you can say make it logical or make it character or make it integer or make it double. If you first make something double, like turn a logical into double, and then turn it into character, it's just going to add quotes to this whole thing, right? So it will first turn the true, false, true into 1, 0, 1, and then if you turn that into character, you'll get quote 1, quote 0, quote 1, okay? Which is different than if you go from logical directly to character, what will turn it from true to quote true, false to quote false, okay? So these are just things you got to be aware of, when we coerce things from one to another. There are some implications of things that happen along the way. Okay, coercions with operators and functions. So we have these functions like as numeric. Okay, other things like an operation like sum. Okay, a function like sum will coerce the values into zeros and ones. So you've got a logical vector. You can just sum, and it will turn it into zeros and ones. And I'll say, oh, there's one true in there, okay? You can also do mean of a logical vector, and because it sees 0, 0, and 1, the mean of 0, 0, and 1 is 0.333, okay? Which is very useful because you can take a column and make a logical statement based on it, right? So you can say, maybe there's a column for gender, and you want to know how many of these people, identify female. So you just say gender equal female, and that's going to produce a logical vector of trues and falses. It's going to be true for people who responded female. It's going to be false for everything else, okay? And then you can just say, well, what's the mean of gender equal female? Then it will give you the proportion of people who identified female in that column, right? So if it was like 45 out of 100 or something, it'll say, 45% or 0.45, okay? It'll give you the proportion. So this is very handy. You couldn't do something like this in C where it's strictly typed, okay? You'd have to go through the explicit type conversions to do that. This is just, you just apply it just straight, okay? The explicit coercions, you can force things as logical, as character, as integer, and things like that, okay? Logical is going to return true for anything other than 0, okay? So you'd say as.logical 1 will return true, as.logical 0 will return false, as.logical negative 0 will be false, but as.logical negative 1 will be true, okay? So anything that's other than 0 or negative 0 will get coerced to true for logical, okay? Character basically will just throw quotes around something if it can, okay, which is pretty simple. And then as.integer will just truncate if it's a number. It'll truncate things. It'll just drop the, oops, I wanted as.integer. Okay, so we got that. It just drops the decimal portion. It's not rounding. It just drops it. Okay. Oops. Okay, so you can take a string that says 3 in quotes, and it can coerce it to integer. And if you take a string that has that looks like a number, okay, it'll turn it into a number, and if it's as.integer, it'll drop the decimal portion. As.double, we'll say, well, that looks like a number, and I can understand this. Okay, is that okay?
If you divide two integers, will the output be a double?
Yes. Division will always produce type double. So for example, let's say A is going to be I can do 4L divided by 2L, right? So 4L over 2L is the integer 4 divided by the integer 2, okay? And if we ask what is type of A, it's going to be double, okay? So the result of division, even if it divides perfectly, the result of division is always type double, okay? Oh, now you got me curious. So you have the mod operator. The mod operator will return an integer type, okay? So modulo. So this is basically the remainder portion. So if you do like 5 modulo 3, okay? It says 5 divided by 3 is 1 with remainder 2, and so the remainder 2 there is going to be I'm sorry. So here, if I did type double, 5 is type double, and 3. Okay, so there's slight differences between these things. Okay, so 5 is type double, modulo 3 type double. This is like too nitpicky. If I do 5 divided by 3 type double using the default types, and I do double divided by double, it's going to return, this will just be type double 2, okay? Whereas if I did integer modulo integer, it will return an integer, okay? All right, well, anyway. So it can coerce, anyway, these things that look like numbers into numbers. It doesn't understand English, though, so you can't put in 1. It'll give you an NA as a missing value, right? So a lot of times you'll get, you might see this warning, okay? You'll see warning, NA is introduced by coercion, okay? Which means something, I was not able to convert the type for all of them. And so when R wasn't able to convert the type for all of them, it's gonna give you an NA, okay? And then if you try to use that in a function later, like an if statement, if statements don't allow NAs, you're going to get an error, okay? And so this is a very common thing that happens to people when they're programming. You got these if statements, and you get, if this is equal to this or something. And these statements, require true and false values, and perhaps the coercion didn't happen completely, right? If you got a missing value, things go on, okay? R is unique and is loved by statisticians and is used for statistics for one of the main reasons is that it has this specific NA value, okay, for missing values. This doesn't exist in many other languages, okay? Other languages have something called not a number, but that's different from missing, okay? So in statistics, we accept that a lot of times there will be missing values when we collect data. We're not able to collect every bit of information, and we like to acknowledge that these values are missing. And so we use NA, and there is a NA for each type of value that we have, okay? So in R, we keep things simple by having only really like 6 basic types, and 4 of them are really the only ones that we use, right? Integers, doubles, characters, logical. Other languages, like C, where you've got the 16-bit integer, 32-bit integer, and then the 16-bit or the 32-bit double and 64-bit double and all of these bits and bytes and things like that, it would require too much computational overhead to have a specific missing value for each type, and so they don't include that. But R has a NA, okay? And if you just type in NA, it's going to tell you the type is logical, okay? And then if you do an operation with NA, it's going to give you back NAs, okay? Because you just have to think of NA as this box where you don't know what's inside, okay? It exists. The value exists, but we don't know what that value is, okay? Which is different from like a null. A null would be the value does not exist, right? So for example, if you have a person and you said, what is the weight of the person? Before you ask the person their weight or before they give you their answer, that value does exist, it's just unknown to us, okay? That's what a missing value represents. It's something that does exist, but it's unknown, okay? Whereas, I don't know, like a nonsense question where the answer just simply does not exist, okay, then that would be appropriate for like a null value, okay. Anyway, so when I do NA plus 1 and I get an NA, it says type double. What happened there? It got coerced, right? This NA got coerced to the type double NA. So this NA is different from this NA. This is a logical NA, and this is a type double NA, okay? We've got different NAs for...
Can you assign the values to the NA?
You cannot assign values to NA. It's like assigning a value to 3, okay? So, can you assign 5 to the value 3? No, okay? NA is an inherent value of unknown, okay? Other special values, we've got NaN, not a number, infinity and negative infinity. These are all type doubles, by the way, okay? These are all type doubles. And don't use the computer to try to prove mathematical constants, okay, or mathematical concepts, right? So technically you can't divide by 0, but if you do pi divided by 0, it says infinity, okay? So you can kind of think of it as the limit of pi divided by 0, right? And then, we have negative 0, right? So if you do pi divided by 0, you get infinity. Pi divided by negative 0, you get negative infinity. Negative pi divided by negative 0 gives, So these are kind of like limits. You can loosely thought of that, but 0 over 0 is going to give us not a number, okay? That's not allowed, okay? And you got positive. All right. So anyway, you don't worry about all of these details and stuff. But so NaN means not a number. A lot of languages treat NaNs as missing values, and for type doubles, we can, maybe think of it that way. But you know what? I got to keep track of the time and where I am located. Okay. All right. I'll let you worry about this quiz because we got to cut through the time here. Okay. R does element-wise operations. So it kind of matches things up, right? So if you have 1:4 plus 2:5, it's doing 1, 2, 3, 4 plus 2, 3, 4, 5. It matches the 1 and the 2 and gives you 3. It matches the 2 and the 3 and gives you 5. It matches the 3 and 4 and gives you 7, so on and so forth. Same thing with the multiplication. It matches them element-wise. If one of the things is shorter than the other, it's going to recycle. Okay, so here I've got 1, 2, 3, 4 multiplied by 2, 3. Okay, so 1, 2, 3, 4 has 4 elements in it. 2, 3 only has 2, so it recycles the 2, 3. So it goes 1, 2, 3, 4 times 2, 3, and it recycles 2, 3. So the 1 gets matched with the 2 gets matched with the 3 gets matched with the 2, and the 4 gets matched with the 3. And so you get this. Okay. If you have something, so 1 through 4 has 4 elements in it, 2:4 has 3 elements in it, okay? The recycling still happens, except it'll just wrap around. So it goes 2, 3, 4, 2. So it tries to match it up so they both are of length 4 by recycling the 2, 3, 4. And then it's going to kick back a warning and say, I'm not sure if this is what you wanted me to do, okay? Because usually I would expect the longer one to be a multiple of the shorter one, right? So it matches up evenly. But here, that's not what happened. So the 1 matches up with the 2 goes with the 3 goes with the 4, and the 4 goes with the 2, and then it stops, okay? It's not an error. It says, I've done it, but are you sure, right? So you get back a warning when you recycle with something that's not of the same length, okay? Can be done. Whereas if you did something like this in Python, called a broadcasting thing, it's going to give you an error. Okay. This is a repeat. Okay, I got it. Okay, so we've got missing values. Oh, okay. Here's a few other things. If you want to check if something is missing, use the function isNA. Okay. Don't say is it equal to NA. All right. So if you say is NA equal to NA, you're going to get missing. All right, because that's this person over here, what's their weight? I don't know. This person over here, what's their weight? I don't know. Is this person's weight equal to this person's weight? The answer is I don't know, okay? That's what this is saying. Is NA equal to NA? NA, I don't know, all right? NA is kind of like an I don't know answer. What you want to do is the answer unknown? Yes, okay? Do you not know that person's weight? That's true, okay? We can say that, right? NA is a value that exists just unknown to us, and so it does take space in the vector, okay? And you've got different NA types. Unfortunately, the NA types are named kind of funny. When you start typing NA underscore, you can see the different kinds that we have. You have NA character, NA complex, NA integer, NA real, and then NA, this is the NA logical, right? This is the most restrictive type, okay? All right, so anyway. So NA real is the type double NA. Null is null. This means the object does not exist, okay? And if you want to ask, is it null? Okay, then you can do that, okay? Is NA null, okay? Gives us a logical 0. What's a logical? So logical 0, or any kind of thing, okay? So you can produce things like logical 0 and character 0. Like if you wanted to get character 0, you can, you guys know about ls? So like if I create the object A takes on the value 0 and D takes on the value 10, okay? I can do ls and this will produce a list, or not a list, a vector of the objects in my global environment. It says you got object A and you got object D, right? And then if you want to remove everything, you can say remove A, okay? And then when you ask list, it says, okay, all you have left is D. And you can also do remove list equals ls, or you can just hit the sweeper, the broom, and that will just wipe everything out of the thing. And if you type in ls here, it's going to give you character 0, okay? So what character 0 means, or it shows, you know, the last value you did was character empty, just means you have, the response is a vector, but it's a 0 length vector, okay? It's a vector without any elements in it, okay? It's a 0 length vector. If you ask what's the type of this thing, it's not null, it's a character type, but the length is 0, okay? If I said, you know, length of ls, it'll say it's a 0 length character vector. Okay, so it's not a missing value. It's a vector of length 0. Okay, which is different from null. Null is something that just doesn't exist. Okay, so you can ask, is the null value null? That's going to be true. Is it NA? Okay, is it NA? Well, it's going to give us logical 0 because it's going to say, well, this thing doesn't exist, but your answer should be true or false. So you're going to get a 0 length vector. Yeah, question.
Only one variable in the environment, and then you type of ls.
You'll get a character vector. So like if I've got a is 0 and b is 10, okay, ls will give me this vector, right? So type of, what is the type of this response where it says a and b? That's a character vector, okay? And when I remove everything, okay, and I ask what's ls, it gives me a 0 length character vector, and if I ask type of here, it's still a character vector. Because the response to ls is always a character vector. It's a character vector where the elements are the names of the objects in your global environment. But if there's nothing in the global environment, you've got a vector of length 0. Okay, I gotta move faster here. All right, is the null value logical? No. Okay, and then if you try to do operations with null, it doesn't let you do that. Okay, and then if you try to insert null into a vector, what happens? It doesn't go in there. I mean, it goes in there, but it doesn't exist. So, you know, it's like eating an air pie or something, right? Okay, just, no, that air actually exists, so that's not even a good example. Okay, all right. Somehow I messed up my thing. Okay, lists. Let's talk lists. We've got our generic vectors, and they're still considered to be one-dimensional, and they can contain values of different types, right? So you can have a character, logical, double, even functions, okay, and they all fit in the any kind of object. They all fit in the list, okay, and they keep the types. They didn't all get coerced to characters or something like that. So lists allow you to do that. You can ask, what is the structure of a list? And it will say, all right, there's 4 things in my list. You've got a character thing, a logical thing, a numeric thing, and you've got a function in there. Okay. Lists, you can nest lists inside of other lists. Okay, so unlike the atomic vector where you tried to combine one vector with another inside another or something, and it just flattens it all out, the lists will retain kind of the hierarchical structure there. Okay, so here I've got a list B, which is a list of 5 in 1. One element of the list is the character vector, is the numeric vector with the value 5. Another element of the list is a separate numeric vector with the value 12 in it, okay? And then C is a separate list, and here, let me just see if I can copy this. Okay, and so when I print out A, it's going to have the hierarchical structure. We've got A has is a list of 2 elements, where the first is a list of 2 and the second is a list of 1. Right? So if I ask the structure of A, it's going to say it's a list of 2, and then the first thing in that list of 2 is another list of 2, and the second thing in A is another list, but it's a list of 1. So you can retain the hierarchical structure. Let me just modify this ever so slightly. Okay. So if we look at B, we've got 5 over here, 12, 13, 14 over here. C looks like this. And when we look at A, it still retains the hierarchical structure. And if we ask for the structure of A, it's pretty much the same. I don't know if you guys can see this. We've got a list of 2. A contains basically the list B and the list C, where the list B is a list of 2, where the first thing in it was a list of 5, and the second thing was a vector, or not a, was a numeric vector with 1 element 5, and the second thing is a numeric vector with 4 elements 1 through 4, or 12 through 15. So we've got all of this. This produces something similar. We're nesting a list with an atomic vector, okay, and it produces that, okay. So the list operator or function keeps creating these hierarchical things. What happens here? Here I used combine. So compare this where I said list, and we've got list 1, 2, and C, 3, 4, and creates a hierarchical structure where X is a list of 2. And here I've changed the first thing from list to combine. Okay, Y is combine, and we've got the list 1, 2, and combine it with an atomic vector 3, 4. The result there is a list of 4. What's going on? This created a list of 2. This creates a list of 4. Why? It's the same thing. All we've done is we've changed list to C, combine. So C will look at the least restrictive type and coerce everything to that type, right? So we've got a list of 2 here, and then it's going to coerce everything here into a list, and it's going to combine them all. And so so that's what it's doing, okay? And so it converted the 3 into a list type and 4 into a list type, and it combines them all, and we've got a resulting list of 4 here. Okay, lists you can name, and I think you're familiar with this. So you can say, you know, A is 1, and B is this, and E is this, and stuff like that. And once you have your elements in the list named with a $sign, you can then reference them by saying, I want $B, I want $sign stuff, right? So here, so this is a hierarchical list where we've got A, example is a list of 3, A, B, and E, and then B within the thing is a list of 2 with C and D, okay? And so when I call for B, I get the list of 2 with C and D. If I call for C directly, I get null, because that doesn't exist at the top level, right? C doesn't exist at the top level. But if I want that element, I can say, give me element B within the example, and within B, I want C, and give me that. And that exists. Okay? So this is a situation where we get null, because it's not a missing value. It's not something that exists where we don't know. It's just this thing doesn't exist. Is there an element C within our top level list? No, it doesn't exist. So then you get a null. You can attach attributes such as names to atomic vectors, okay? So X is an atomic vector. What is the type of X? The elements of X are the numbers 1, 2, and 3. So X is a type double vector, okay? Those values 1, 2, and 3 have names, L, M, and N, okay? And so you can ask for the attributes, and it will say, oh, the attributes, we've got these names, this character vector L, M, and N, okay? So attributes, all attributes is it's just a separate list, and you can access them this way using the attributes function. Okay, you can because attributes is a list, you can create any information and throw it into this attributes list, okay? So here we're just going to create a new thing called my attributes, and I can write a paragraph and it says this is a vector or whatever it is, and it's going to be stored there, okay? So the vector x is still just a numeric vector, a type double vector, 1, 2, 3, and then it's got like this separate tag of information that we call the attributes with all of this other stuff. It's got names, it's got this and that, and that's what happens there, okay? Here we change the names to A, B, and C using the built-in letters vector. And so that we've got that, okay? Again, you can write any kind of attributes and store that information in there, but probably the only attributes that we care about are names, dimension, and class, all right? And so we've looked at names. Dimensions are used to create matrices, or effectively. Okay, so you've got an atomic vector and you have a matrix. They're both atomic types. The matrix has dimensions. The atomic vector does not. Okay, and then if we're dealing with some kind of object, like a factor or something like that, then that information is stored in class. And we'll look at object-oriented programming in a couple of weeks here. So here's our thing X that we created earlier, and it's got the names. You can subset that, and it preserves the names. And we can, this page just talks about creating names and all of that. All right, we've got couple of minutes left, and I want to talk about factors, and you've got some questions in your homework exploring this thing, okay? So factors are used to kind of store categorical information in a kind of a data frame, right? So if you want to say, I don't know, did you start at UCLA as a freshman, or are you a transfer student, or are you something else, right? So let's say we've got three values, right? Freshman, transfer, or I don't know, started as freshman, transfer, and I don't know, other, okay? And like if you're exchange student or international or whatever it is, okay? We might want to store that as information, and rather than having to write every single thing out, we can store that as a factor, okay? And so here we've got this thing, and factors will inherently have certain levels that are allowed, and if a value doesn't exist as one of the allowed levels, it's not going to let you input the thing as a factor. When you look at the type of a factor, it's going to say it is an integer, okay? What it's doing is it's coding that value. I'm a transfer student. It's going to say, okay, that's going to get the integer value 2. I started as a freshman. That's going to get the integer value 1. Okay, and so it stores the information as integers, 1, 2, 3, or whatever it is, and then there is a separate thing called levels that will match up that numeric integer to kind of the label that we have. Okay, and so that's how we have to keep in mind. And so you'll have questions about factors, and just be mindful of that. Okay, read through the notes on your own time for more information about factors, and we'll see you guys on Friday.